All right, well, hopefully work time has been successful and hopefully you got the chance to answer these questions. I'm going to go ahead and go through and answer them right now as well, and you can check your work. So, as we stated earlier, when you have an exponent raised to another exponent, you can actually just multiply those exponents. So this is the same as 1.05 times, or to the 1/12th power times 6. Now, when we have a whole number times a fraction, the rule is still applied that you take the whole number and you multiply it to the numerator. So I'm going to have 1.05 to the 6/12ths power, or 1.05 to the 1/2 power. That's the answer for that first one. Okay, a negative exponent. Now, hopefully you remembered from the last lesson, or you checked back to the last lesson maybe, to look at what does that negative exponent do, and that makes it takes the reciprocal. So it puts it in the denominator of a fraction. So now we've got 1.05 to the 1/12th in the denominator beneath 1, just like that. Okay, this is number 9. Similar to the other one that we had, so it's 1.05 squared times 1.05 to the 1/4. Up here, when we had the bases being multiplied that were the same, all we had to do is add the exponents. So it's 1.05 to the 2 power plus 1/4. Now, if we go ahead and add that, you could say it's 2 and 1/4, but having an improper fraction in an exponent is kind of goofy, so we're actually going to, having a mixed number, so we're going to make that an improper fraction. Improper fractions are okay, mixed numbers are wonky. So we'll do 2 plus 1/4. Well, if I wanted to make those into an addable fraction, I would have to say, okay, 2 is now 8/4, so that they have common denominators, plus 1/4, okay? Because 8/4 is just the same thing as 2, but I wanted them to be common denominators, so now it's 9/4. So the solution will be 1.05 to the 9/4 power, okay, just from that little addition right up there too. All right, so now you have to use a couple of different, if you remember the rule for dividing bases with exponents, that will be helpful. But if you don't remember that rule, then we're going to have to be a little creative, or you may have needed to be creative. So remember that if a negative, just like in number 8 up here, the negative moved our 1.05 to the denominator, we could actually pull our denominator up and say it has a negative exponent. So we could say 1.05 squared times 1.05 to the negative 1/2. Because we know what base is being multiplied, what to do with those exponents. We know to just add them, right? So it's 1.05 to the 2 power minus 1/2. So if we just add those, it would be plus or minus 1/2 technically, but then you just have minus 1/2. And I'm going to add those and say 1.05 to the 1 and 1/2. But as I said just above, that mixed number and the exponent is kind of grody, so I'm going to make it an improper fraction by saying 1.05 to the 3/2 power. Now, that's a way that we could have been a little creative if we didn't remember the rule that just says if you have the same bases being divided, all you have to do is just subtract the denominator's exponent from the numerator, just like that. And that'll give us 1.05 to the 3/2. Okay? All right. Now, let's say this. Number 11, use 1.05 to the 1/12th power raised to the 12th power equals 1.05 to explain why 1.05 to the 1/12th power equals the 12th root of 1.05. Now, there are a couple of different ways you could do this, and I'm kind of intrigued to see what you guys came up with. So maybe when I get back, we'll take a look through it. But probably the smoothest way to do this is to say, okay, how do I, in an algebraic equation, how would I get rid of an exponent? And I know the answer, just like I would get rid of x squared if I said x squared is equal to 4. To get x by itself, I have to take the square root of both sides, right? Now, in an exponent that is larger than 2, I have to take the root of that same value. So I'm going to take the 12th root. Now, if I do something to one side, I have to do it to the other side. So now I have the 12th root and the 12th power canceling off, just like that. And I'm left on this left-hand side with 1.05 to the 1/12th is equal to the 12th root of 1.05. So that just little bit of opposite operations is enough to explain why we've got 1.05 to the 1/12th equaling the 12th root of 1.05. Okay, that's everything. Remember, if you have questions on your RSG, please email them to me so I can put up little tutorials for next class or in between classes, and you will be good to go. All right, thanks, y'all.